So how many times have you watched a movie about space and of course something blows up, usually the bad guy, and you hear a giant explosion out in space? It looks great, there's fire everywhere. Well, I hate to tell you, but a lot of that is made up. Out in space, a couple things really don't work as far as explosions. One, you don't hear sound out in space. The old adage in space, no one can hear you scream, is true. I mean, if you're on the space station and you're chatting with somebody else and someone sticks you with a needle, they'll be able to hear you scream because you're inside the space station, there's air that's pumped inside and sound can travel. But once you get out into space, without any air, without any oxygen, there's nothing for the sound waves to travel through, so sound doesn't travel. So here at the H.R. MacMillan Space Center, we have this vacuum jar, and in this way we're able to try and replicate what goes on in space, which of course is a vacuum. What I'm going to do is I'm going to start this up, we're going to get that bell starting to ring, but we're going to remove all the oxygen from around the outside of it, or at least as much as we can, and listen to what happens to the sound of our bell. Now again, as we remove that air, it gets quieter and quieter and quieter, and that's because the sound no longer has any air to travel through, and sound has a difficult time making it through the vacuum of space. And again, in a true vacuum of space, you wouldn't be able to hear a thing. And speaking of explosions, let's say you don't want to have an explosion out in space. One of the most important things for a spacecraft is being able to withstand the heat of re-entry. And what we want to do is try to test different materials and how they conduct heat. And here we've got three different materials, carbon fiber, copper, and stainless steel. We have a heat lamp underneath, and this is a very good visual display of how this material generates and conducts heat. Our carbon fiber is hanging out at about 24 degrees, our copper is up around 41 degrees, and stainless steel is at about 33. So you'd want to say, hey, you know what, I'd want to make something out of carbon fiber because it doesn't conduct that heat. It's not going to bring that heat into the spaceship. Now for the shuttle, they actually use these very special heat tiles, and they have hundreds of these on the bottom of the shuttle, and they're able to withstand temperatures of over 1200 degrees and dissipate that heat really, really quickly. So if you're coming down in a spaceship and you want to try and get down through our atmosphere, there is going to be heat, but using the right materials, you'll be able to protect yourself, the crew, and the spaceship, because these things do a fantastic job of taking that heat in and basically dissipating it very, very quickly. At the H.R. MacMillan Space Center, I'm Cam Cronin for The Express.